The next step of this exercise will consist in modifying our swap array function so that this time the parameters are declared as int star p1 and int star p2 instead of int p1 empty square bracket, int p2 empty square bracket. This change will not affect actually the functionment as you already tested of this function, and this change will not ever even affect the way that we have to write this function. Why? Well, let's start by answering this question. At the first level, you do not have to change the code of the function simply because of the equivalence between array notation to index an array, that is, for example, p1 index I between square bracket, and the equivalence of this notation with the pointer arithmetic notation. So whether p1 is a pointer or the name of an array, you can use both the square bracket notation and the pointer arithmetic notation. If you are not sure of the reason of the equivalence of those two notations, I refer you back to the textbook, and more importantly, I refer you back to the forums, where I expect you to post a question asking for clarification about this equivalence. This is a very important thing, otherwise, if you don't understand that, you will not be able to manipulate arrays really efficiently. The second point is, why can't we use a pointer declaration here as a replacement, a drop-in replacement of the int p1 empty square bracket notation? The reason here is that, as we have seen already in the previous step of this exercise, when you call your function with a1 and a2, let me scroll up to the main, when you call your function with a1 and a2, you are pretty much putting on the stack the address of the first element of array a1 and the address of the first element of array a2. The int p1 empty square bracket notation allowed us to receive that address and treat it as an array, p1. Okay, well, it makes sense that we can also consider that since an address is put on the stack, we can also consider it as being something that we want stored inside of a pointer p1. However, if this explains why the function is working, this doesn't really clarify whether or not you should be able to use those interchangeable notation outside of the declaration of parameters of type array. The answer is clearly no. You can only use the equivalence between those two notation, int star p1 and int p1 empty square bracket, when you are dealing with parameters of type array. To make sure of that, let's go to our main and try to declare an array named ANOVER, like we did here with a empty square bracket notation. So I'm popping up the code here. This is where I inserted my declaration here. I'm going to save this file, make sure it's saved, and we are going to try to compile it with Conqueror. Here's Conqueror, gcc a03.c. Error. So it's not even a warning, it's an error. Array size missing in ANOVER. Go back to the code. What's happening here? Well, here, using the parameter notation was not acceptable when trying to define a local variable. And you will notice that I switch from the term declaring to the term defining. We are going to try to be a little bit more formal about how we use those two terms from now on. Defining a function means giving its code. Declaring a function means just giving its header to facilitate the job of the compiler to check if you are calling it correctly. The same goes with variable. We won't have very many occasions to play with the subtle nuance between declaring and defining a variable until the end of this course. However, this here is an example of why the difference actually matters. And I'm going to just give you an explanation in a nutshell. When you are dealing with parameters such as here, you are declaring your parameters. Okay? When you are here inside of a function or even dealing with a global variable, you are defining those variables. We are going to come back onto the situation, like I said, at the end of the course. Okay, there is a little bit more to that story, but for now, let's stick to the simplified version. What is the difference? Well, for an int variable, there is really no difference. Look at how I declare int size. Look at how I define int size. Same thing. When you are dealing with arrays, a difference can start showing up. For example, this is the definition of an array A1 of size. Because it is a definition, that means everything I need to know about A1 is present there. I know that A1 is named A1. It's an array of int, and I know how many ints are in that array. Why? Because as soon as I enter main, I need to be able to save some room on the stack. Allocate some room on the stack for this local variable. So there we go. I need to know everything, the total size of this variable. Now, what is the difference with declaring P1 as an array of int parameter for this function? Well, in this case, I do not need to specify the size. Why? Because everything that's going to go on the stack is simply the address of the first element of the array that will be passed. So the effective parameter A1 has a size, fully specified. The parameter P1 doesn't need a size because it's going to represent just the address at which start this array. And this is why we have this equivalence between this notation and this notation. This is an equivalence that is correct only in the context of array parameters. Now, when I try to write here int and over empty square bracket, I am in the main function. I'm dealing with a local variable and over, which I'm trying to define. Well, define means that I need to give all the information. In this case, I do not know how big this array must be. So when I enter the main, I cannot create this array because I have no clue about its size. Okay, so define, you need to know the size, the complete size of your array. Declare an array, you don't need to know the complete size. P1 is just going to act like a pointer, like an alias on wherever this array is starting. So this answers exactly this question. Okay. First, what is a compiler error? Does that mean that we are allowed to define an array without size? Absolutely not. We cannot define an array without size as local parameter, as local variable, as global variable either. The only way where we can use this notation that looks like array without size is when you pass arrays as parameter to functions.